Hey everybody. So I don't think this video will be very long. This is mostly just review for the math part of your packet, and I think most of everything that you'll be able to explain to your child or they'll be able to figure it out for themselves. There are a few things that I'll go over just that I think might be a problem, or maybe I can show you a different way to do it that might make it more efficient and more easy for the child to understand. So I'm just going to kind of mix all of the days together. So just one video this week for math, and of course, that's all I'm going to make a video for. So if you need me to help with anything else, like in reading or something like that, or anything else that's not in this video, please let me know, and I will do that for you. So this is the first thing that I want to talk about is on Monday. On the back of the sheet, the one about the leaves, it introduces centimeters. I believe this isn't the first time that this has gone home in a packet, but I never got a chance to teach centimeters to my kids. We were going to until all of this happened. So I've gone over with my kids that you have something on your body that is about an inch long, and it's this. So from the tip of your thumb to the first knuckle, that's about an inch. The older you get and the more you grow, the closer it's going to be to an actual inch. But it says from the tip of your thumb to the first knuckle. That's a good mental benchmark for inches. It's not a perfect inch, but it's pretty close. So it's just for them to kind of look at and just to get an idea of how long one is, so that way they can put like an invisible inch on the edge of an object and move it around to estimate how long something is in inches, if that makes sense. So same thing for centimeters. This is what I was going to tell them for centimeters. If you imagine a brand new crayon, this tip right here to about right here, so the tip of a brand new crayon is about a centimeter long. So look at the difference. Let me do it this way, between an inch and a centimeter. As you can tell, my thumb is much longer than the tip of this. So try to pretend that the paper part of the crayon's not there. That's about a centimeter. So look at that. Inches are bigger. So that is what they can use to help them estimate with centimeters. Okay, and so let's notice that we are taking 9 away from different numbers within 20, so subtracting 9. I wanted to show you a few strategies that you can try with your child that are pretty efficient once you get really good at them, but you have to have pretty good number sense to be able to do this. So the first strategy that you can use is the making 10 strategy to subtract, which I've made videos about before. So 17 is my whole. I want to take away 9, part of that 17 away to see what I'm going to have left. So instead of taking away all 9 at once from 17, let's make this 17 a friendly 10, and then we can take away the rest. So right here, I have 17. I have a 7 in the ones place. Well, what can I do to 17 to make it 10? To make it 10, I would have to take this 7 in the ones place away. Well, I can only take it away if I'm supposed to. I'm supposed to take away 9. So instead of taking away all 9 at once, let's take away 7 first. Now, is 7 and 9 the same thing? Are they equal? No, of course not. You're going to have some left over. You're going to have 2 left over because part whole, 7 plus 2 is 9. So don't forget that part. We still have to take that 2 away later to make sure we're taking away 9 when we're done. So let's do 7 minus 7 is 0. That's 0 in the ones place. I have 1 in the tens place, which is 10. So I have 10 now. And so now it's just a friendly 10 partner problem. If I know my 10 partners, this is easy. So 10 minus the 2 that's left over would be 8. So 17 minus 9 equals 8, because 8 plus 9 equals 17. So that's one way that you can do this. All right, let's try another way. This way is kind of like what I like to do, which is adding to help me subtract. Again, 17 is my whole. 9 is a part. I want to figure out what this other part is. Well, I could take away 9 from 17 to do that, or I could add to 9 until I get to 17. And whatever I had to add to get to 17 is the other part. So I'm going to take 9 and I'm going to add 1 to it to get to 10, because 10 numbers, adding to 10 is very easy. So now I want to get back to 17 from 10. What would I need to do to add? What would I need to add to 10 to get to 17? 7. 1 10 and 7 ones. So now you look at what you had to add. You had to add 1 and a 7. 1 and 7 make 8. So 17 minus 9 must be 8. All right. Now, one of the kids, or a few of the kids actually, used this a lot this year, and they thought, since 9 is so close to 10, let's treat this problem like it's 17 minus 10. So 17 minus 10 is easy because for the kids that have really strong number sense and good place value knowledge, they know that when you add a 10 or take a 10 away, the ones place is going to stay the same. And it's easy to add 10. And it's easy to take away 10. So if you lose this 10 because you got to take 10 away, you're only going to have 7 in the ones place left. So 17 minus 10 is 7. But you got to remember, the problem wasn't 17 minus 10. It was 17 minus 9. We're just using that to help us. So since we took away 1 more than we were supposed to, because 10 is 1 more than 9, you have to add that back to what you have left, your difference, which is 8. So again, we took away 1 more than we were supposed to, because this is 17 minus 9, not 17 minus 10. But then, using what we knew that we had to add 1 back to make sure we didn't take away 1 too many. So when we did that, we were left with 8. So 17 minus 9, again, is 8. So try that with the kiddos. These are very efficient strategies. It may not seem like it right now, but the more you understand place value and the better number sense you have, this can be done within seconds with practice and with understanding. So it may not seem efficient when I'm drawing it out like this, but for the kids that have strong number sense and good place value knowledge, they're doing this in 1 or 2 seconds or less, just because they have a really good understanding of the relationships between numbers. So it is possible for your child to get there too, if they're not. All right. So counting money. Some of you hopefully saw this on the videos that I made earlier this year when we started with money. But if your child is struggling with counting the normal way, so counting by 25s, then by 10s, then by 5s and 1s, use hairy money. We want them to be able to count in chunks and for the order not to matter. But for the kids that have weak number sense and don't understand the relationship between numbers very well, that's going to be very hard. So this is something that they can do to be independent. They can help them get to the right answer while they are trying to count, I guess, in those chunks that we're used to counting. So the way hairy money works is that you have let me do it over here. You have 1 hair that looks like this, and 1 hair equals 5 cents. So for every 5 that's inside of your coin's value, you're going to add a hair. So like for quarters, that's 25 cents. Now your child has to know that. They have to know what a quarter is, and they have to know it's 25 cents to do this. So I know that counting by 5s, I can get to 25. 5, 10, 15, 20, 25. I have to count by 5s 5 times to get there, which means that my quarter needs 5 hairs on it. Okay, a dime is 10 cents. 5, 10. 2 times I had to count by 5s to get to 10. So my dime will need 2 hairs. A nickel, 5. Just 1 time, so 1 hair. Now the penny, I tell the kids that the penny's bald because it doesn't have enough value to get a hair. So he's bald. So we would count him by 1. But your quarters, your dime, and your nickel, you would eventually count. You're counting by 5s the entire time until you get to your pennies. And this makes it easier for the kids that are struggling with number sense and counting patterns and those number relationships that are so important to help them still get to the right answer as independently as possible. So this is how it would work. 5, 10, 15, 20, 25, 30, 35, 40, 41. So this right here would be 41 cents. Okay, so let's come down here and practice on this one. So how much is a quarter? 25 cents. So we need 5, 10, 15, 20, 25. 5 hairs. Same thing for this quarter. 5 hairs. For the dime, I need 2 hairs because 5, 10. 5, 10. 5, and my pennies are bald. So now I can go from here to here and count by fives the entire time until I get to the ones. Just be really careful because when kids get into the habit of counting, and we adults do it too, you get so used to counting by tens or so used to counting by fives that when it's time to change what you count by, you just keep going and you get the wrong answer. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 76, 77. So 77 cents for that group of coins. All right. Down here, I believe this is Thursday or Friday. You have a line plot. Wednesday, you have a line plot. So for those of you who don't know what a line plot is, it's just a way for you to show data, kind of like a graph, but it's using a horizontal line, and you use X's to show amounts. So the label's really important. So this is going to be about the length of hair on some dolls. So this girl, Samantha, in the word problem, measured her dog's hair in centimeters, and she recorded the lengths on a chart. So here's our chart right here. Here's our list of lengths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 measurements were made. So that means by the time we're done with this, we should have 10 X's. Okay? Now I tell the kids that this is kind of like a number line. And instead of starting off with 0 and then going all the way to like 100 or something, just take a look at your smallest measurement, your smallest number in your data. Start with that. That'll save you time and space. So the smallest number in our data right here is 7 centimeters. So instead of starting with 0 and going 0, 1, 2, 3, 4, 5, 6 and having nothing there, just start with 7. Okay, we know that we definitely have 8, but even if we didn't, if we had measurements of 9 but not 8, you can go ahead and put 8 there. It's okay to have a couple of blank spots in the middle. We just don't want a bunch of numbers there that we're not going that weren't on our table, if that makes sense. And the highest number in our data is 10. So we could stop this at 10. I'm just going to go ahead and go up to 11 or 12 just for the heck of it. But there's no need for me to keep going after I get to my highest number because we don't have any hairs that were 11 or 12 centimeters long. So I could stop there. Okay, so now I'm just going to go through and I'm going to start and I'm just going to look for all the 7s that I see. And I'm going to cross them out as I'm done so that way I don't miss anything and that way I don't accidentally forget one. So we have one hair that was 7 centimeters long. So I'm going to put 1X above 7 because one doll had hair that was 7 centimeters long. Okay, so that X is one doll. Now I'm going to figure out how many had 8 centimeter long hair. No, 1, 2, 3. So there were 3 dolls that had hair that were 8 centimeters long. So guess how many X's I need to show above 8? 3. All right, let's see if we had any that were 9. 1, 2, 3, 4. So we had 4 dolls that had lengths of 9 centimeters. See how my numbers are spaced out to where there's no way that you can get these X's mixed up. None of these X's look like they belong over here or over here. I'm trying to keep this as neat as I can on a computer. All right, any that were 10. 1, 2. And that's all of them. So again, I had 10 measurements because we had 10 dolls, which means when I'm done, I'm going to go back and count and make sure that I have 10 X's. If I do, then my line plot is most likely correct. 1, 2, 3, 4. 4 more makes 8, and 2 more makes 10. And I have crossed out all of my data. I double checked and make sure that I didn't forget anything. So that should be the end of my line plot. So hopefully that made sense. If there's anything else that was not on here that you would like me to make a video about, please let me know and I'll help as soon as I can.